Above, above we'll see a list of perfect cubes. And we are able to obtain each number in this pattern by taking 1 times 1 times 1. So 1 to the third, 2 times 2 times 2, 2 to the third, 3 to the third, 4 to the third, and so on. Okay, so completely factoring this. The biggest misconception students have is they're used to factoring binomials, and now we are working with cubes. In this case, we can have addition or we can have subtraction, and we're still able to break this down. Now, 143 is here. It is 1, 2, 3, 4, 5, 6, 7. So 7 times 7 times 7. I'm going to show my work. 8 breaks into, it's the second number, 2 times 2 times 2, and this is divisible by 3. Taking 3 divided by 3, you end up with 1. So I have 2 in the first parenthesis, and we have 3 in the third. This is always addition. This problem, we are provided subtraction in the middle, so whatever the given operation is goes in this place. The next operation is always opposite. Okay, we're going to slow it down here. Notice the 7 and the x's come before the operation, and the 2's come from behind. In this place, I'm going to grab one item from the front, one item from the back. Now in this place, I'm going to take the remaining items from the front, and we're going to multiply them, not add. 7 times 7 is 49, and there's 2 x's. Same concept in the back. 2 times 2 is 4. Now in this middle place, we already have the sign, and that's a big confusion. So you already know the sign. We just have to come up with what's the numerical value and what's the variable that goes there. We're going to multiply these. 7 times 2 is 14, and attach an x. Done. Let's go down to the next, 24 and 81. Well, 24 and 81 are not on this list, so what do? I'm going to write it off to the side so we can see this. 24x cubed minus 81. So I'm focusing first on the numbers, and I'm noticing again that 24 and 81 is not on the list. So I'm going to take the smaller of the two numbers. Where would it be on this list? It would be right here is where 24 would go, in between 8 and 27. So I'm going to take that 24 and I'm going to divide by the numbers going to the left to see, am I able to factor out a value that then leaves me in parentheses with perfect cubes? Let me demonstrate. Okay, here's where 24 is, and so I'm going to move to the left. 24 divided by the first number to the left is 8. If I get a whole number, that's golden. There's a whole number. So I believe that I can divide this number by 3 and I end up with a perfect cube. What, 24 divided by 3? Awesome, perfect cube. Let's try the next one. 81 divided by 3, 27, also a perfect cube. So I'm going to start by factoring out the numerical value of 3. Factoring in 3 leaves me with 8x to the third minus 27. 8 is 2 times 2 times 2. 27 is 3 times 3 times 3. This is divisible by 3. And as a quick reminder, with our cubes, when we are doing the sum or difference of cubes and we are factoring, and factoring is just another way to rewrite things in equivalent form. We can have addition or subtraction in the middle. So 3 stays on the outside. This is always addition. Now this symbol comes from what we're given. So we're given subtraction, and opposite of subtraction is addition. I'm going to grab one item from the front, one item from the back, and then cross them out. And then I'm multiplying. 2 times 2 is 4, and we have 2 x's. And multiplying 3 times 3 is 9. Now in this space, I'm going to multiply up front. 2 times 3 is 6 with an x.